Hey everyone, welcome to the R Masterclass project building session. In this session, we are going to build two projects, and our first project is COVID-19 dashboard. So, if you remember right, in 2019, COVID was high on its peak, and in the news there were a lot of data visualization there. So, one example you could see that there is Zoho Analytics, and they have this bar plots and this map plot, and you already remember how to build this plot. So, what we are going to do is we have already the data set that we need from this website, and what I will recommend you, I will add this link to in the end of the lecture course material so that you could download this data set. But basically this data set have the time series data for confirmed deaths and confirmed recovery. So what we are going to do is we are going to take this data set, clean it and use it for all for our prospect. And now let us come back to the context. So on 31st December, right? Let's look at what is COVID-19. So before you build a data visualization plot, there needs to be added. The first thing you need to add is some context. So here we are adding some context. So uh, World Health Organization on 31st December 2019 alerted several cases of pneumonia in Wuhan city, which is a city lies in China. The virus did not match any other known virus, and because it does not match any other known virus, this raised concern that it's a new virus and we don't know how it will affect the people, and this causes panic in the people. So daily life, so what it was, it's a very communicable disease. So if you come in contact with any other person, you might have got a chance that you might get affected. So daily level information on the affected people can give some interesting insights when it is made available to the broader data science community. So what people did was the data set was available publicly, and they were trying to build some data visualization onto that, and which was helpful for other people to look, okay, the cases are going up, now it's coming down or not. So that was the prospect idea. So here John Hopkins University made an excellent dashboard using the affected data cases, and they made it available to us, that the data set we look onto. So what I want to show you now is the John Hopkins University made a website. So now let us look at and get inspired from this. So if you come to the provided link, this is the dashboard they made, and this is, you could easily made this based on time series plot, a bar plots, stacked bar plots, and you could easily create this one. And then we have a map plot, and then we have daily cases and number and incidents. So what we are going to do is we are going to make a simple dashboard which will have this map world and weekly cases, weekly deaths, weekly dose administrator. We will see what we could plot in the dashboard, but uh, you could take inspiration from this plot, and now in the lecture we are going to look at how we could plot this. So if you are curious how I download this video dataset, here's the button to download it, and it's you need to download a zip, and once it's downloaded you need to keep it, and in upcoming few seconds I will tell you to extract it and keep it in where. So now let's look at the data visualization process. Now let us look at some data visualization process that is involved during your building your data visualization. So basically in any data science thing there are four parts. First part is your data, getting the data. So first part is where do you get the data from. So once you have collected all the data, remember we have collected our data from the given link, And once we are getting the data, what we need to do is data wrangling. And the data wrangling is the similar term used for just for cleaning, transformation, and or reorganizing. So we do to call all this term means data wrangling. Then we use analysis and visualization process to determine general trend in COVID-19. Like you're given data, and we try to find some trend based on the visualization. So now let us look at the code and how you could code this out together. So now I have opened my R console. Now what I have to do is basically remember we have downloaded the code previously, so we just need to the downloaded what I mean. So now I have opened my R Studio, and if you remember, we have already downloaded our dataset. We just need to extract and set our working directory there. So what I will do is basically I will take that downloaded file and put it onto the same folder. Now what I will do is basically I will set my working directory to this code. So either you could type a command or you could directly use GUI. So this is my project that I have saved onto, and this is my downloaded file that I have saved where the data asset is, and this is my working directory where is my code is. So why we have done this? Basically to get the data set, it will be easy for us to get those data set. So here you could see what I'm trying to do is basically trying to import those files, and here this code what it's doing is just saying, hey, go to this file location and update, get the code. So here there's something needs to be updated, that is this is should be inside. So now what we need to do is we need to tell where the file is. So it's inside the or archive folder, and here you could see it. So go inside the archive folder. So what I will do is basically I will cut those code and basically update this code, and this is inside archive, and let us check if this is correctly working or not, and we will run the rest of code again. So it's saying that it cannot able to find read.csv. Why? Because we haven't imported those package. So now what we need to do is basically import the CSV method that in which the package is. So before we import the data set, we need to import the libraries, remember. So basically we weren't able to use read CSV method. So what we need to do is first we will import our library and then run it. So if you are getting something like there is no package installed tidyverse, so you could directly install it or you could run a command. So we also need one more package that I will show you how to import it. So once it's here is your time lapse, and this is basically how you use GUI. So basically if you haven't any library, the R Studio will always ask to whether to install or not. So once you have imported it, what we will do is we will import another library. So library, and then we will need to call the method that we need to import is ggdark, and you could see that this is there is no package called ggdark, and to install it through command prompt is install dot packages, and you just need to add those. So either you could run directly use GUI or you could directly enter here, and it's saying install.packages not found. So let's see if install dot, there is typo. So let us look why it's not installing. So the reason why it's not installing is because there is some typo. So install.packages, and this needs to be inside a string, and we haven't put this inside the string, so it's giving us a error. So now hopefully this should work, and it's going to our screen where our packages reside. It's similar to pip for Python, if you remember, use familiar with Python. And once it's ready, so we could now run our code. And let us first do the following thing: remove all the environment variables. And it's saying confirm.csv does not exist, so we'll try to see where is the missing link. So there was a typo that this needs to be confirmed underscore us, and the issue was we need to set a working directory. So I have uh, here you have to come to the gear icon and come here and just click on set as working directory. Basically it will set up your working directory, and then what's done, you just need to update the time file location, which is time series COVID-19, which is this file. And once we enter it, control shift enter, we are able to get the TS confirmed. Now we need to do this for similarly for other plot as well, that is for recovered, for deaths. And we need to have one more file, that is read.csv, that we will look into. So what I will do is basically replicate this code for other as well. So I will just copy this, and then I will replicate this code for TS recovered, and here we just need to change for recovered cases. Then what we need to do is we need to import for death as well, deaths, and then we just need to just replicate this similar code here. And if you are looking at this code and you might wonder what this end line means, basically here this what is this is basically, if you look at what does this code do, provent state is equal to call characters. But basically what it is basically we have this code, right? And if we able to import data set, and if we see here that the country region is a character data set, so we need to tell the read CSV method that this country region and province state is a character data type. So you need to import it as a character, not as any other data type. So here, for example, if our code include this and it uses other data type for this, for example string, it would be difficult because this is numerical value and we can't treat it as a string. So that's why we are telling our code to just maintain those. And if you looking at this is just a CSV file, comma separated values that you don't need to scare off. So we have imported deaths and all those things. Now what we need to do is we need to get the country code. So basically if your country code is +91, so like it's for India, so it should be able to map those to the your province area. So for this there is already data set available, that is from Plotly data world GDP with codes, that I will show you in here below. And let me go to the new line and let me paste it. And basically what it is basically, if you look at go to this code, is basically it's world GDP with codes that we need, and basically GDP and code we need from this. So that's why we importing this data. And if you need to look at what this data set is, either you could look it from here, or you could go to the link that I have provided. So you get the code, right? AFG, Alabama, and all those code we need to get those. So we have got their GDP as well. So we will have some idea related to, okay, some country have this much GDP and their annual spent on vaccines or any other thing, we could get those. So now it's time to move on to the next part, that is or pre-processing. Let us type pre-processed data, and it's a very good way of habit to have comments on the code. So we will type pre-processing data. So if any other user see this code, they will know, okay, we are pre-processing it. And what will we do is basically, if you look onto our code, right, ts covered, and you might find this thing, the date column. For each date we have separate rows, and we don't need separate columns for each date. So what we will do is, we will create only single column for dates, and we will add those into. So what we have done is basically gather date and from the recovered proof instance, and add a column, that is date column. And similarly for ts recovered and deaths. So basically we are saying call the gather method, and we provide the data to be the date, and the key is the confirmed values, and then the C, where is the column province, state, country, large, region, latitude, and then we have said mutate the data, which is consider or date as a new column and create one. So once I enter those, you could see our data must have been verified, and now we have only 6 variable with dates added onto it. Now we have got an idea, okay, those are done. Now we need to do one more thing, is that we need to get the total cases. So to get the total cases, it's basically total date, total confirmed plus total recovered plus total deaths, right? Because that will give us the whole total cases. So what will I do is basically run a total code, basically gives us the total cases. So basically total cases, and I have already written this code. Basically I will just give you an idea what we are going to. So ts confirmed, ts total is total confirmed plus left join deaths, and left join it's recovered. So if I open confirmed data, deaths, and we have the ts recovered. So what is left join? So left join is basically the data set that is common between ts confirmed and ts dates. So let me go through the excel draw, and I will explain you this in very much briefly. So here is the basically a join statement, and there are 4 types of join statement, basically inner join, outer join, left join, and right join. So basically let us look at the inner join. So in inner join, what happen is, suppose you have two data set 1 and data set 2. The inner join is considered to be the common of both, that is known as inner join. Full outer join is known as the combination of table A and the combination of table B and the common part also. Left outer join means you have suppose data set A B, and you have data table A, then the table A with the commonality between table B also. And right outer join is similarly, but for opposite, table B but the commonality of table A also. So joins, where are joins basically used? And this is basically similar to discrete mathematics. If you remember, in your 12th, I think the discrete mathematics is there, but we don't need to dive deep into that formula thing. But basically joins are used in SQL lot, because we have lot of data set, and from those data set we need to get some few data set, suppose commonality thing, then we use join table. Let's say we need to get the common data, we use inner join. Suppose we need to get the combined data, we use right join. And suppose we need to get the table A, but we need to get the commonality of table B also, then we use left join, and similarly right joins. Now we have got an idea, okay, what left, right, and inner outer join is. We could now move on to the code and understand what we have done there. Now, once you have got an idea, okay, what is left join is, we will look on to what is TS total and other code is. So TS confirmed is basically the left join of TS deaths, that is the commonality of between the TS confirmed and TS recovered, and then we mutate into and create another variable that is recovered and replace any values with 0. So if there is any values that is 0, then we replace it. And then what we have done is the another cleaning step that we have done is the TS total. So we have removed any nonsensical country region. So for example, that there is following values, that is Diamond Princess and MS Zandam, which is basically a cruise ship in which COVID was also detected, and but in the dataset it's where there, so we need to remove that as well. And then in the last, what we need to do is basically, if you look onto this code, what is saying is that we need to remove any death value have any values with 0. So let's look onto the code that how we are doing. So TS total, get the death column, and if is NA, that is if it contains any NA values, then replace the total deaths value by 0. So if I enter this, control shift enter to run the program, we will be able to get all the NA values for death to be removed. So if I open TS total, you will be able to see that there is no NA values here, and you could do similarly for other as well, that is recovered and confirmed as well. Now we need to get the cases latest, and to get the cases latest we need to create a command. Basically it's a type of SQL command, and what we need to do is we need to get the latest by any date, which is the date which is recent. We need to get that latest at the top of the trend. So now let us look at how we could code this. So I have got this code to get the latest code, basically latest cases, and I will give you an explanation. Basically, lot of this command is based on SQL, and you might wonder what is SQL is. It's a coding programming language for manipulating dataset. So a group by command in SQL is basically get the country region by the dates, and then we summarize the content, that is confirmed deaths. We sum the data, we get sum the data for the recovered, and we sum the data for the deaths, and then we create a new variable method, that is mutate new case is equal to confirmed and minus lag confirmed by percentage. So what it does is basically it shifts the value by 1 day. So this calculates the number of new cases by subtracting the day from the previous current day. So we get the new cases by shifting the one column by 1 day. Basically we adding a lag, so we could get the new cases previously to the 1 day, and then we trying to get this thing by max date. Basically it's for the date which is maximum in the data set, so which is basically means only the latest data set. So in here max data means basically we are getting this data set for the latest date, and then in the last we are saving the max cases in the day latest variable. So if I run this, you'll be able to see the latest date that is available in the data set, and you get an idea. Okay, so here's the latest data set that is available, that is for 2021 5th of month and 29th date, and here we have cases latest based on those. So here is the latest data based on that particular date. So we have 191 observation out of total. We have something about 135k, and you get a whole idea that how much data set we include. So if I run this, I got the latest data. Now we have cleaned our data set, we have covered up all the latest data set. Now we are going to see how we could code out the plotting thing. Now let us code out the rest of the thing. So we need to get the codes, and we have already get the codes from this. So we will get this code and basically create a world visualization plot, which will be more understand once we are done with it. So we'll get the codes data set, and in this we need to get the or country and the code. So we will select country, and then we will select the code, and then from this what we need to do is basically create a rename or region with country code as well. So region, and this is will be set to country, and then we need to rename the code. Sorry, we need to rename the code from our code thing. So we will create a code, and this will be our codes, and then we will map this to the column ID. So row names to column, and then if we able to see it, then we just need to map to the ID. So let us save it, and it's saying that unexpected input, and whenever you have some kind of a bug, it's a good chance that you try to figure out yourself, because it's opportunity to grow. So basically we have a typo, and there are chances that that you might get lot of uh, typo in R, basically because of its odd structure in coding language. But here we are able to get the country codes based on the data set we have and the region. So what will I do next is basically create a region based and replace the string from our total case. So here in the code region, if you get this latest, we have this all this code, but some of this country region doesn't have standard name. So basically for uh, uh, for for example West Bank, so it should be replaced by with West Bank and Gaza. It's including Gaza. There are some cases that we need to consider. For example, United States, but its standard region code is US, so we need to replace that as well. So I will just copy this code and show you that what I'm doing. Basically, this is what I'm doing is code ID is a integer part that we have done is. So this thing code latest, in our codes we are representing the ID as an integer part. So that what we are doing through this, and then what we are making is that making sure the country region are properly aligned with the standard name. So basically we are going to replace United States with US, with Macedonia with North Macedonia, Czech Republic with Czechia, and then all those things. So basically we are doing this because once we create a global plot, we need to get the standard name. And here with the cases latest codes, what we need to do is left join that we have the latest case with the codes that we have created. So we are casing cases latest with the codes we have created by the country and the region name. So here our common column is country region, and then we are arranging it with the descending form of the confirmed. So if I run enter, we'll be able to get the whole idea. So now we have got our latest case based on the case code, and here we have with latest code cases with their standard name. And here you could see the top 3 region lies with this latest COVID confirmed cases, US, India, Brazil, and then top 10 we have France as well. But you could see the number rising for both, for US, India, Brazil are very higher. Now let us plot a data visualization plot, uh, that is a globe plot. Basically for this we are going to use geo map method that will plot or geometry 3D plot. So if I look at plot geo, and it instantly plot a geo object, and if I run F1, we'll be able to provide the data frame, and we need to provide some standard data set. Now let us see how we could code this out together. Now here I have wrote down some code that I will explain you what it does. So basically what we are trying to do is basically plotting a world COVID-19 test total case by day, and here we are trying to plot total number of recovered versus death. So here what we have done is we are getting all cases from our total data that we have created. So if we look at our environment variable tab, here you could get all those data from our case latest date variable, in which we have all the data regarding the confirmed deaths and recovered. So we are going to plot those thing, and what we are going to do is basically we are going to plot deaths and recovered data. So we, for this to plot this, the first thing in your mind should come is the bar chart plot. And if you remember, in the bivariant plot we plotted stack charts that we are going to use to plot it. So basically here we use our deployer package to get the total confirmed cases and new cases from the cases total date, and then we called bar chart, and then we called our geoplot function to plot the total cases based on aesthetics x, which would be our date, and for other plot we are plotting is in which or would be a y would be our confirmed values would be a, and it would be stacked upon each other and denoted by red color. And similarly we are doing for the bar chart for all cases, and in this we are plotting for the recovered cases, and then we provide our title to be a GG title world COVID-19 total case by day, and then we let our legend to be at the orientation of horizontal, and we passed our ggplotly method directly to the bar chart variable. So we called ggplotly method, in which we passed our bar chart plot. You could see here that it needs to provide a ggplot method which includes a plot, and here we are providing a ggplot created a ggplot function, and in this variable we it is stored in bar chart, and then we are passing it to the ggplot method. And once we call this function, sorry, this is a function, and once we call this function we could get this plot. And looking at this plot, what you could infer is basically you could see that the number of deaths precedes the number of recovered. So if you look at the number of deaths, you could see that it is more than the number of confirmed plus number of deaths. So it's the highest thing. So the number of recovering was very less in COVID-19 than the like more people were dying instead of recovering. So that's, we get an idea from COVID-19 total cases by confirmed, and now we have got an idea, okay, total number of deaths is more than the total number of recovered. Through this data set we have plot. Now what we could do is we could plot more visualization plot. What we could do is the next we are going to plot is the mortality rate and recovery rate. Now we need to see, okay, what's the recovery rate for this and what's the mortality rate for this plots. Now what I have done is basically created a mortality rate graph, and what we are going to look at onto is basically I have created a bar chart one variable and in this I have selected a date and recovery rate as my data parameter to select from the case total data uh, data set, and from those I have selected the date and the recovery rate variable, and then from those I have gathered the ratio date, and then I have plot the aesthetics of this. And basically it's a geometrical bar plot that we have plot, and we have added some theme color to it. But we once I have once and then I have laid out the passed this variable into ggplot function, and in this I have also called the layout method. Basically what it is basically for to uh, get the legend into the ratio, so in horizontal orientation. So we have this recovery rate legend which is on the horizontal uh, orientation, and then we are able to see that the recovery rate ratio is very less. So what is recovery rate ratio? Basically total number of case and the number of people recovered at that particular day, and you could see that it's very unstable, that it's increased, that was good, and then it decreased, and then it increased again, and then it decreased. So it's very unstable, and this is not very good for a country that have like for us, because the recovery rate was not increasing. It was very absurd, like it was increasing for few days and then it decreased. So it was very challenging, and then people were trying to find vaccine, because at that time vaccine was not also there. But what we could do is we could also check the mortality rate. So I will select only the mortality rate and try to find out. So I have changed only one part of the code, that is, let us calculate the mortality rate, and let's try to find out the other plot. So here we have the mortality rate also, but it's very much similar to the recovery rate. It's very also unstable, that it increased for few time and then it decreased and then it increased. So it's also absurd that mortality rate was also what basically mortality rate is basically the number of deaths per by total number of total case. So it's good if the mortality rate is increasing and the recovery rate is the mortality rate is decreasing and the recovery rate is increasing. So that way you are able to find out, okay, we are recovering from the mortality from COVID-19 cases, but in this that wasn't the case. The mortality rate was also absurd, and the recovery rate is also little bit absurd, because it was increasing and then it decreased for few times. Now we have got an idea, okay, what was the mortality rate and recovery rate. Now let us try to plot some representation, okay, by top 10 regions that which country have. So what we'll do is basically we'll now plot top 10 region with confirmed deaths and recovered. I have written the code for the top 10 confirmed cases based on the country region. So what we are doing to do is basically top 10 confirmed cases all over the world, and we know that top 3 was US, India, Brazil. So what we are going to do is we are going to plot it. So top 10 confirmed cases, the latest cases, and then we are selecting the country region confirmed, and then we arrange it by descending order, basically by the number of highest most would be on the top. Once done, we create a bar chart variable. In this we get the top 10 confirmed, and from that we get the top 10 values of it. So here we use a slice operator that get us the top 10, and once we get the top 10 we reorder by it country region, and then we get the confirmed value, and then we plot a geometrical bar. We provide all the data to it, and then we use minimal theme and create a continuous scale so that it does not break, and then we provide labels to it. So once you run it, you will be able to see that the most confirmed cases were from US, India and Brazil, and we could already see this in our first plot, if you remember, right? The first plot that we made, we were able to see that most were from US, India and Brazil, which already depicts in this. So if I give you a challenge now, I have created top 10. What you need to do is you need to create a top 20. So how will be able to do this? So basically, to do this, you need to first add the top, instead of uh, using the top 10, the slice operator, we are able to get the top 20. And here we also need to update our title. And you might be thinking, what does we have to do with the title? But when you make the plots, it's necessary to add the titles, because other person could easily understand your plots. So here we have the top 20 plots, and in the top 20 we could also see the most of the countries were from Europe that were added to this plot. So now our next thing is, this is based on the top 10 confirmed cases. What do we need to do? What if we need to make this for our top 10 most death case? So how will you be able to do this? So what we need to do is, basically I will increase my editor. So here's my editor, and what we need to do is, we need to get the top 10 by deaths. So similarly, I will code it out. So top 10, and then we need to get it by death. So we will create a death variable, deaths, and then in this we will store the top 10. We get this value by top 10. First we need to get the death number of deaths in particular in each country. So we will call cases, and we call latest, and then we call this operator, percent operator, to select by country region that we need to do it. And then basically, once you select it by country region, then we need to select it by deaths. And once we selected it by deaths, you could easily add this symbol to this operator to basically get arrange this based on the descending format by deaths. So if we run this, we should be able to get our code run, and we should be able to get top 10 confirmed deaths. So here we are able to get all those data. Now what we need to do is, we need to create a bar chart variable, so that will create have almost of the data into it. So it's similar to this code also, above code, that in which we create top 10 most confirmed case. The code is basically similar. So top 10 confirmed, top 10 deaths. In this we'll use this operator. Basically what we could do is basically create a bar chart operator, and in this we let's say we make it for deaths, and in this we create a operator. In this we select deaths, and in this we need to have only top 10, and we select a deployer package that should also satisfy this condition, that it should be the a ggplot. So now here we'll add ggplot case to draw our ggplot, and in this aesthetics we could say that x is or will be reorder on the number of cases by the country. So either we could easily copy this code line. That we need to do is, so I will copy this code of line and just update it, and instead of confirmed we need to do it for the death. So I will change it for deaths, and let me check if the deaths by the deaths. So if it's singular or plural, so it's by deaths. So once we are done with it, we just need to create a minimal graphics, like minimal visualization thing. So that's what we are doing with the theme minimal, and then we create tell to create the geom bar plot method. We create a geom bar method, and thus we provide stats to be our identity, and it filled it with the red color. Next we call this method basically to plot our graph, and basically in this we will call the bar chart method, bar chart dex basically, which is a type of a ggplot. And let us wait to see the top 10 most confirmed cases. But here's some error that we need to look out for. So I will say that can't substrate column by the location 349. There are only 2 columns. So let me fix this error and come back to it. And now we are able to plot it, but basically there was few typos that I want to show you. The first typo was this needs to be ggplotly, and the next typo was we need to add a plus operator. Now we are able to get the top 10, but what we need to do is basically call a method called coordinate flip to flip this plot to make more sense of it. So we will flip this plot, and we'll also need to add the titles and as well as the scale for this. So what I will do is basically copy this line of code and paste it again here. So and top 10 most confirmed, most death cases, and here we are able to get the most death cases plot. And here we could see India ranks on top, then Brazil, Turkey, and luckily US does not lies in this, which is very much surprising. But we got an idea, okay, which country lies on the most top of this deaths. And now what we are going to do is basically got an idea. Now it's your time to do this similar thing basically for the most recovered cases. So what I will do is basically re-replicate this code again, and what I will do is basically copy it again, this line of code, and we'll do it for recovered case. So for the recovered case, what we need to do is we need to first update the variables, and in this we need to get this variable by recovered. So we'll change this by recovered, and here this needs not should be death, it should be recovered, and in the last we need to arrange it by recovered. So here we say recovered, and once we get this we need to create a bar chart recovered method and top 10 recovered method, and here we are slicing it by top 10 recovered country region, and here it should be recovered. And let us change the fill color to be green, to be changed with this other plots. Now it's okay. So top 10 most recovered cases, the recovered cases, and basically this needs to be bar chart recovered. So hopefully I'm thinking this should be the code now needs to be worked on first attempt. Let's see, if not we will fix the error. So let us run it and see if there is any error or not. So I think the recovered cases would be also on the top 3 would be India, Brazil and Turkey. Basically you could see that most of the cases that have been recovered is from also India, Brazil, Turkey. And if you are running late like previous version of this code, like on previous version of data, basically this code would be different for you, the plot would be different. Why? Because the number of cases were from the latest cases from like if we check the latest cases, date, and it's the latest case date is from like, if we need to 2021 5th or 29. So if you are from getting the data from previous latest date, this might data set be different for you, so the plot might be different for you are getting it. So you could see the Brazil, India, Brazil have most of the recovered cases, and you might not able to see US because the US data set was not available. I checked that, and it was for previous as well, which is little bit absurd that for we have total cases but not for the uh, recovered and most death cases. We don't have that data set. Now we have got all the idea. Let's just see last plots, that is further analysis with most affected region or places. Look at the next plot, that is what we are going to do is, now once we have plotted all the data for top 10, top 6, now we are going to do it for particular regions such as for France, Italy, Russia, Spain and United Kingdom. So basically we are going to do this for 6 countries, and what we have done is basically we take those country and try to plot those uh, total confirmed deaths and recovered. So here what we have done is we selected the country region, and then we called a filter that filters out the country region based on this uh, vector variable if on that data set. So it selects only this country from that particular data set. So we only have data set available for only top 6 affected countries. So if we look at the variable thing, you will be able to get top 6 affected, and based on this we have only 6 region data set available, that is for US, Spain, India, United Kingdom, Russia and France. So I have changed Italy from India to check what's the change in the trend. So basically in first try I did it with Italy, now I want to check it with the India parameter. Then we grouped it by country region. We tried to get the summarized confirmed cases and recovered total cases, and then we changed the name, that is we passed new cases, just change to get the latest date. We changed the date by date 1, and then we get the recovered cases by recovered by total cases. Then we get the mortality rate by number of deaths. Then we created a new cases. We get the recovery rate and mortality rate based on this, and we then handle some any values. If there is any values in new cases recovery rate or in the mortality rate, we just replace it with by 0. That's what we have done, and then we have called the ggplot method. So what we have done is, here is we created a plot, ggplot and sorry plot name variable, and in this we passed the top 6 affected data set we have created. In this we want to get the filter out the data before the 7th of 14th 2014 date, and then we wanted to get all the following variables data, so country, region, date, confirmed, recovered and deaths that we need to plot. So we gather all those data, cases, names, and then we created a bar plot with the color red color, and the aesthetics x would be your date and y would be your cases, and then we filled out the latest names, and we created a facet of grid type, and legend position we added to the bottom, direction bottom, and all those data to it. And once let us see run it, because this time it would be different because I have added India as another parameter instead of Italy. Let's see what changes we see. There's no change, but there is slightly increase in the all three things. So mostly recovered death and confirmed case were increasing, deaths were increasing, and recovered was also increasing. So there is sharp increase in recovered, but then generally there was a sharp decrease also. The confirmed cases were similar itself, the confirmed cases were increasing in trend, and here we could see that the number of confirmed cases, deaths and recovered were increasing, both three were increasing, but there was some ambiguity in death and recovered. Basically, it increased and then decreased and then increased. So it was not a general way that it was only decreasing and then increasing, but it was we wanted it deaths to be decreased and recovered we wanted to be increased. So that was a good trend, but it did not follow that trend. So now let's look at few more graphs that we are going to look onto. Now what we are going to do is we are going to create a recovery rate graph like this. In this we have this points that we will do this, and to create this plot we need to first create a, let us say, interactive plot that we are going to create. So we will name it to be interactive plot, and here we are going to plot the recovery rate, and to get the recovery rate, from where we will be able to get the recovery rate. So we are going to get this recovery rate from the total 6 affected data. So from here that we have created above, we are going to get this data from this total 6 affected area, sorry, top 6 affected area that we have. So we'll get this data, and then we will call percentage and get method. So to rename the names, which should be country region, and then what we are going to do is basically call the ggplot method. So here we call this function, and then we call ggplot, and then we called aesthetic method, in which we provide x to be our date, y will be our recovery rate, and then where y is our recovery rate, we pass it by the groups. Basically we have like renamed this group names to be name. Now once we have done this, let us see our plot, and then we will improvise it. So okay, so the plot is not showing because we need to call a ggplotly method to show the graph. And if you remember in our previous lecture, we don't need to call this, but we are using ggplotly, so it's having some issue with ggplot, so that's why we need to call ggplotly method. If it's this code is working for you, like without need to call ggplotly method, this should be working, like you don't need to call the use ggplotly method. So basically I have some issue with ggplot. When I use plotly, it doesn't work with ggplot, so you need to explicitly call ggplotly method and call it. So basically here we have this basically have the typo here, in which we need to fix it. It should be plotly, that I fixed it. And then what we need to do is we need to add the data to it. Basically the data have not been added, and that's why our graph is showing us empty. So what I will do is basically call geom line method, and in this aesthetics I will call the color to be by names, and alpha to be about 0.9, and then let us see how our graph look like if there is any plot. We also need to add point size, and here we could see that names does not found because it's by name, and we also have to add the point, geom point based on the line. So geom slash point, and here we need to provide aesthetics and size. So we will provide the size to be like the size of 0.5. 6 is also good, no issue. And the alpha is just basically the color ratio. So basically if your needs to be have more color, you could add like its value is from 0 to 1. If the more it close to 1, it's more opaque it is. So that's the idea. And now we'll just add few more line of code, that is basically scale color and the title to it. So, and whenever you build a data visualization code, you try to run it one, like in between of your code, instead of directly coding out in one go. Basically it gives you idea. So here it's saying some error, could not find plus comma function, and if we try to debug this, we could find out. So the issue was that we have a typo. Instead of name, it should be names. Remember that we name into the names. And here we have the recovery rate. Now once you have got the this plot, you try to interpret things. So if you look at the recovery rate, since the case was more, the recovery rate was India was also too high. In Russia it was the similar condition, but you could see the recovery rate was similar to India, and for the rest of the country they did not have that much great recovery rate, and also they have very less case. So basically you could see that recovery rate is increasing, and also we saw that their case was also low. So that the chance of this thing is that the recovery rate was decreasing as well, and all the case confirmed cases was also decreasing. Now we have got an idea of how to plot all those things. So currently we, you could see we already have lot of plots here, and we have looked at each plots in very much depth and detail. And what you could do is, I will post this code into my GitHub. You could clone this code and try to play with it, and try to get the idea of it, that what is happening in this code. So what you could do is, once you create a code, I will create this code, I will what I need to do you to do is, you need to change these colors, and you need to create your own kind of graphs. Remember stack graph, you could create those plots in between India and Brazil, and create a pull request to my GitHub repo. So the GitHub code repo would be in the course material section of this course, and you could use this code to build your, like, create a pull request, and I will check your code and see how far you have come. So with this, the first project is completed, and in the next lecture we are going to look at the next project that we are going to build. And with this, thank you for following till now, and I'm happy you have come till come this far to the course, and I will see you on to the next lecture. Thank you everyone.